What is going on, guys? My name is Amos and I'm back again with another video. So in today's video we want to look at le raisonnement par l'absurde. So this is also another way of trying to show or trying to justify that a certain proposition is either true or false. So now this is based on the fact that the proposition or non P implique Q et non P implique non Q. So this is equivalent to P. So this is actually based, le raisonnement par l'absurde, this is based on this proposition. So now this looks a little bit long and it's a little bit hard to understand. But what we're trying to do is that given any proposition P, so we'll actually suppose that the opposite is true. So we'll start by supposing that the opposite is true. Then our goal will be to look for a proposition, say, let's say Q, that is going to be true. I mean, we're going to look for a statement, say Q, for example, that is going to be both true and false at the same time. Now, we know that from the previous videos that it is impossible to have a proposition that is true and false at the same time, or that is going to be given the name contradiction. That is going to be known as the contradiction. So when we arrive at a certain contradiction, then the proof is done. We would have had our result, would have gotten our result or our confirmation. So given any proposition, let's say P, we suppose that its opposite, that is non P, is what? Is vrai. So if the opposite is vrai, we now try to look for a proposition Q that is going to be, or a statement Q that is going to be true and false at the same time. Now that is impossible, so the statement is going to be known as a contradiction. So that is going to be the end of our proof. Now let me just write down what I've said. So given P, now this P is a proposition, so it can be an assertion or a predicate. So this P is a proposition. So our goal will be to, our hypothesis, so our procedure is going to be that, well, non P, the non P is vrai. And then our goal will be to look for a certain proposition Q. So look for a proposition Q that is true and false. So basically, because this is impossible, we cannot have this. So this is going to be known as a contradiction. So our goal will be to look for a contradiction. Once we arrive at that contradiction, then the proof is done. So now I know you guys have already looked at some problem. Maybe let's say now a classic example that I can give you guys here is that the square root of 2 is irrational. Let P be the proposition that the square root of 2 is irrational. So our goal will be to try and show that the square root of 2 is what? Is irrational using le raisonnement par l'absurde. So, alors, je commence. So I'm going to take care of this top part. Alright, hopefully you guys have copied and have gotten a few notes or a few points from what has been written. Alright, so now let P be the proposition that racine de 2 est irrationnel. The square root of 2 is an irrational number, irrationnel. So I might get this wrong, but hopefully you guys are getting the point. Racine de 2 est irrationnel. So I might get the spelling wrong, but what we're trying to do is to show that the square root of 2 is not a rational number. So this is our proposition P. Remember, what is our step? Our hypothesis is that the opposite of P, which is non P, so we're going to say, okay, racine de 2 est rationnel, est un nombre rationnel. So est un nombre rationnel, est un nombre rationnel. So this is our non Q. So our non P is the square root of 2 is not irrational. Other words, we're trying to say that the square root of 2 is a rational number, right? So this is going to be what we are going to suppose as true. So we suppose this as true. Our goal is to now look for a contradiction. Our goal is to look for what? For a contradiction. So let's start to now look for that contradiction. Well, if the square root of 2 is a rational number, then the square root of 2 can be written in the form P divided by what? P divided by Q. Now, where here Q is not equal to 0 and P and Q have no common factors. Have no common factors. P and Q have no common factors. So this is what we are trying to, this is what we take into consideration. Well, let's now proceed with our calculation. So now if I take the square on both sides, I'm going to have 2 is equal to P squared divided by Q squared. Now this is going to be 2Q squared is equal to P squared. Now what this shows is that P squared is even. So this is our conclusion from this. P squared is what? P squared is even. Now if you guys are having doubts, or maybe this is not true, well, if a number is even, so if a number is even, it can be, if a number n is even, it can be written in the form 2k. Now where k is an integer. For example, the number 8 is the number 8 is even because it can be written in the form 2 multiplied by 4. In this case, k is 4. So an even number can be written in the form n is equal to 2k. Now if I pause, maybe let's say if I let c be equal to q squared, this is going to be written in the form 2c is equal to p squared. So our conclusion is that p squared is even. Now this implies that p squared is even. P squared is even. Now, in the first video where we were talking about le raisonnement par contraposé, we actually showed that there's an example where we showed that if n squared is even, then n is even as well. So what this is also going to further imply, that p is what? Is even. Alright, this is also going to further imply that p is even. So let me just take care of the top part so that we can continue with our calculation. So p is even. Oh, what if p is even? Then it can be written in the form. So if p is even, even, so this is small letter p. Capital letter P is for the proposition p, the proposition that I gave in the beginning of the question. So if p is even, it can be written in the form p is equal to 2m. So now where this m is an integer. All right, now I'll substitute this 2m in this equation that I have here. Let me just say 1. So I'm going to substitute my p there. So I'm going to have 2q squared is equal to well, if I put 2m here, I'm going to have 4m squared. If you divide by 2, you're going to have q squared is what? Q squared is equal to 2m squared. Now this is going to imply that q is even. So if q is even, based on the example we had in raisonnement par, in the video where we talked about le raisonnement par contraposé, if q squared is even, then this is going to imply that q is what? Is even. Whoa, check this out. P and q are even. So if both p and q are even, it means they have a common factor. So that is going to be the 2. But here we've supposed that p and q have no common factors. So we've arrived at a contradiction. So we've arrived at our contradiction. So this is going to be our contradiction. So because both p and q, both p and q are even. So this is going to be a contradiction. So this is going to be a contradiction. So let me just write that properly. So this is going to be, we've arrived at our contradiction. So if we arrive at a contradiction, this means that the square root of 2 now, the square root of 2 is irrational. We've shown that the square root of 2 is irrational. Thank you guys for watching, and I'll see you in the next video.